Why am I spending my summers at IIT Kanpur? I am Roshan, an electrical engineer undergrad from GSV, and at the Control Dynamics Lab under Professor Abhilash Patel, I am building motors that can basically think for themselves. So, here's the problem: DC motors aren't as predictable as they look. Friction, resistance, even the load, they all drift with heat and wear. So, a normal controller like PID that assumes fixed values slowly get worse and worse at its job. That's a real problem for robotics and precision manufacturing. So then, what we can do? My solution is an adaptive backstepping controller. It doesn't need to know the motor's parameters upfront. It estimates them while running and adjusts itself. First, I run a 8-second open loop voltage sweep to nail down the electrical parameters offline. Then, a real time Lyapunov based adaptive law takes over, learning the mechanical parameters, inertia, friction, load, while the motor tracks the moving target. The mathematics guarantees the tracking error mathematically converges to zero. In this, along the way, I have found a hidden failure. Trying to learn all the six parameters once backfires. A controller gets so good at tracking that it kills the very error signaling the electrical parameters need to learn from. They got stuck at 70% error. So I split it into three phases: identifying electrical parameters offline, adapting mechanical ones online, then lock everything and track. End result: all six parameters converges to within about 1% of their true value, and position tracking error shrinks to almost nothing. So, why did we do all this? What's the need? These are the motors that recalibrates themselves as they wear down or heat up. No manual retuning needed. No need to know their exact motor specs beforehand. That matters for robotics, EVs, and industrial drives, where the downtime for recalibration is very expensive. Adaptive backstepping controller teaching the motor to know itself. Thank you for watching.